All right, let's talk about AI search. We're all getting pretty used to it, right? But today we're going to go way beyond the standard stuff. We're going to explore what happens when your questions get really, really messy and how a whole new way of thinking called agent search is stepping up to the plate. Okay, let's get into it.
So you've got an AI assistant, and it's probably great at finding documents and answering simple questions. Is feature X supported? And that's useful for sure. But honestly, that's table stakes now. The real test is, can your AI handle the kind of complicated, layered questions that businesses grapple with every single day?
Just take a look at this question. This is not a simple search. I mean, you're trying to compare two different things, Nike and Puma. You've got fuzzy language in there. What does product-related differences even mean, or differing sales outcomes? And on top of all that, it's asking for a cause, a reason why something happened, not just a fact. This is the kind of question that, if you can answer it, unlocks some serious value.
Now, if you throw this at a standard RAG system, that's Retrieval Augmented Generation, it's probably going to hit a wall. Hard. It's just not built for this kind of complexity. See, it's trying to find that one single perfect document that answers the whole thing in one go. And for a question like this, let's be real, that document almost never exists. And that right there is the core problem we're digging into today. We need to understand exactly where RAG runs out of steam and why the real world, with all its messiness and ambiguity, demands something more.
So here's the breakdown. RAG is awesome for simple, single-shot questions, but the second you start juggling multiple things like Nike versus Puma, or you use these vague terms, it just gets lost. The best way to think about it is this. RAG is like a librarian who can go fetch you one specific book from the shelf. But what you really need is a whole research team that can go read a dozen books, pull out the important bits from each, and then write a brand new report just for you.
And that's the big shift. We have to move from just retrieving information to actually thinking like an agent. And this isn't just a small tech upgrade. It's a completely different way of looking at how we find knowledge in the first place.
The logic behind it is actually pretty simple and, frankly, beautiful. Instead of trying to swallow that giant question whole, an agent does three things. First, it breaks it down. It decomposes it into smaller, bite-sized sub-questions. Then it goes out and finds the answers to each of those little pieces. And finally, this is the magic part, it puts all those answers together, synthesizing them into one single coherent response.
So let's go back to our Nike and Puma problem. An agent wouldn't even try that massive search. Instead, it would start asking smaller, smarter questions. Things like, okay, what products did we talk about with Nike? And, in a separate search, what were the issues Puma reported? Each of these is a tiny, solvable piece of a much larger puzzle.
Okay, so the theory makes sense, right? Break it down, search the pieces, put it back together. But how do you actually build that? Well, let's get into the weeds and look at the real-world engineering choices the team at Onyx made when they built their very own agent search system.
Now, the Onyx team had a pretty demanding shopping list. They needed a system with a ton of control, something they could easily change and add to later. They needed it to do a lot of things at once, that's parallelization, to keep it fast. And critically, they had to manage all these logical dependencies, making sure you don't start step C before steps A and B are totally done.
They basically had two paths in front of them: build the whole thing from scratch or use a framework like LangGraph. Building from scratch gives you ultimate control, sure, but it's slow and a total nightmare to maintain. LangGraph, though, it hit this sweet spot. It gave them that high degree of control they wanted, and it already had stuff like parallelization built right in. The Onyx team had this great quote. They said it was a "their pictures look like our pictures" moment. The way LangGraph visualized workflows just clicked with what they were trying to build.
So they went with LangGraph. But, choosing the tool is just the first step. Then came the really hard part, actually building the thing. So let's dig into some of the super practical, hard-won lessons that the Onyx team learned from being in the trenches.
And the number one biggest challenge they ran into? Orchestration. It all came down to managing this complex dance of dependencies and parallel tasks. When you have dozens of little steps, and some can happen at the same time while others have to wait, making that flow efficiently is everything. Because at the end of the day, speed is a feature, and it's crucial for the user experience.
And this is exactly how they cracked it. Look at the difference. In a simple sequential flow, tasks are just sitting around waiting for each other, taking 13 seconds. But by grouping related tasks into what LangGraph calls subgraphs, they could run whole chunks of the process at the same time. This shaved off 3 critical seconds. Now, 3 seconds might not sound like a lot, but believe me, when a user is staring at a screen, it's an eternity.
Another sneaky problem they ran into was this thing called mutable state. Okay, imagine you have a shared whiteboard, and every single part of your system can walk up and scribble on it. If you get a weird answer at the end, how in the world do you figure out who scribbled what and when? It can turn into an absolute debugging nightmare. Their solution was so simple, but so clever. They made a rule. Define all your inputs without any default values. What this does is, if a connection between 2 steps is missing, the whole thing just crashes immediately. And that's a good thing. Instead of silently failing and giving you a garbage answer down the line, you get a loud, obvious error right away. It made the entire system way more robust and easier to debug.
Okay, so now we get to the big finale. Let's see how all these pieces we've been talking about, the question decomposition, the sub-searches, the parallel processing, all those tough lessons, how they all snap together to create the final system. Every single concept we've covered is like a Lego brick. It's a node or a connection in this much larger structure. And yeah, it's a complex web of logic, but it's all pointing in one direction, to finally be able to answer those tough, messy questions that normal systems just choke on.
And what you end up with is a graph. It's basically the brain of the whole operation. You can see the nodes for each step, breaking down the question, running those sub-searches, and then at the end pulling it all together to synthesize the answer. It's this incredibly powerful and flexible architecture that can handle a simple search just as easily as it can handle one of those super complex agentic queries.
But you know what's really exciting about all this? For the team at Onyx, this amazing system, this isn't the finish line, not even close. For them, this is just step 1. They see this as the foundation for a future that is way more agentic, way more capable, and can deliver even deeper insights.
And that brings us to the final question I want to leave you with. The most valuable insights in your business? They're probably not just sitting there on the surface. They're hidden in the connections between different conversations, different documents, different teams. Your data holds the answers to these incredibly complex questions. So the real question is your AI smart enough to ask?